All right, this is a continuation of optimizing area and perimeter, but this time we're talking about restrictions when we're optimizing. Now, what it means by restrictions, it could be that the length and width must be whole numbers. In other words, when we took the square root of area to get the side length, notice in our one example we had ended up with a decimal, so it could be that they've put a restriction on that. Also, there might be a physical barrier, such as enclosed using a wall. And you often see that someone's making a flower bed or making some kind of stall, but they're using a wall um, as one of the sides. And there's other possibilities as well. Now, one of the things that we really need to know, and it's very important, is the maximum area or minimum perimeter always occurs when the length and the width are the closest in value. Okay, so there's different ways to get our measurements, our length and width, but when those length and width are the closest in value, that's where the minimum maximum area or minimum perimeter occurs. Okay, so let's look at our first example. We'll talk about it. So first of all, we have a rectangular garden is to be fenced using the wall of a house as one side of the garden. And the garden should have an area of 40 meters squared. So it asks us to determine the minimum perimeter. Okay, in other words, the fencing is going to be required to go around this garden. So first of all, what we're going to do is we're just going to draw just a really quick basic diagram of what we're talking about. So we have a wall and we know that we want a perimeter around it. Okay, so really what we're doing is we're calculating the amount of fencing required. And notice at the back we don't need a fence because we're using the wall. So if we look at what we know about area and perimeter, in this case our perimeter is different in the sense that we only have one length and we have two widths because our second length is against the wall. However, the area remains the same as with length and width. So the first thing that we need to do is we need to substitute the information that we do know. Now we do know the area because they told us the area needs to be 40 meters. So that's the first thing I'm going to do is I'm going to take that formula, substitute in 40 equals LW. Now the problem with this is I have two unknowns. I have L I don't know, W I don't know, and I can't solve it using this equation by itself. And here I have three unknowns. So that's pretty useless to me. So one thing we are going to do is we are going to rearrange this so that we have something that we can work with. So I'm going to solve for W. So if I want to have W by itself, I'm going to divide both sides by L. So I end up with 40 divided by L equals my W. So knowing what I know so far, I'm going to have to do some thinking. And there is no easy way to do this. So what we're going to do is we're going to set up a table. And I've just created a quick one here. And what I'm doing is I am going to substitute in my values. So I'm going to start with a length of 40. Now my width here is going to be based on this formula here. So if I'm choosing 40 as my length, I end up with 40 over 40, which means my width would have to be 1. So the way we are doing this column is we are taking this formula and using it to calculate our width. And our perimeter obviously is going to be from that formula. So what we're after in this question, we want to minimize the perimeter. Now using the length and this formula for the width, we can actually always, we will have a perimeter that will always have an area of 40. All right, so let's start with if it length was 40, then I know my width is 1. And so my perimeter would be 40 plus 2 times 1. So we end up with 42. If my length is 20, I end up with 40 divided by 20, which would give me 2. And again, I end up having 20 plus 2 times 2, which would be 24. And I continue going through here at 10. This would calculate to be 4. This would be 18. So you can see we have to do a fair amount of work here. And so if this is 5, then we have this as being 8. And if that is 8, we end up with 21. If we have 4, it's 10, and this would be 24. All right, notice what's happening to our perimeter. We started up high, it went down, and now it appears to be going up again. So let's go down further. And what I'll do is I'm just going to extend my page a bit. So now what we do is when it's at 2, we end up that this would be 20. And my perimeter would be 42. Again, notice that I'm getting too high again, 40, and this would be 81. All right, so you can see that I do have numbers that are closer to each other. It appears that there's something going on around the 10 mark, and you can see that. So I'm just going to highlight that with the yellow. You can see at 10 it's 18. Now I did skip a few numbers, okay? So I'd have anything at 11 and I didn't have anything at 9 or 8. So what I'm going to do is I'm going to now take a closer examination of the numbers in this area in order to find out what the dimensions would be. Oops. Oop. Touched the wrong spot. And let's see if I can bring this table back to life again. And you can see that sometimes technology is wonderful. Okay, so what I've done is I have injected some other numbers in here so that we can actually take a closer look at what's going on. So there's our 10, and we knew that when it was 10 that we had the width was 4 and the perimeter was 18. Now what would happen when it's 11 now? Well, when we take a look at what happens at 11, well, when I substitute 11 in for my length, I end up with 40 divided by 11. Well, obviously that's going to give me a decimal number. And if I look back at the question, it says it must be whole numbers. So that's why we can't use 11. What other numbers can we not use? Well, if I look at all the ones I've done here, 40, 20, 10, 5, 4, 2, and 1, all of those go evenly into 40. Now, what about 9? Well, 9 doesn't go into 40 evenly, so we can't use that. What about 8? Well, 8 I think we can. So 8, when I do 8 in here for my L, I have 40 divided by 8, which gives me 5. And my perimeter at 5 then would be 21. 8, 5, oh, no, it's not 21. Sorry, I was looking on the other side. It would be 8. Okay, so we're using this, so we'd have 8 plus 2 times 5, which is 10. So it would be 18. Now 7, can I use 7? Well, 7 doesn't go into 40 evenly, so I can't use that. 6 doesn't go evenly, and 5 we've already done, which was 8 and 21. Now what we need to do is we want to look at the numbers that are the smallest under the perimeter. And when we do that, you can see that the smallest numbers appear to be 18. And it happens in two different places. It happens at 10 and 4, as well as 8 and 5. So what this means is there are two dimensions that this person can do in order to have a minimum perimeter. Right? So these types of questions take a lot longer because you have to do a lot of I'm not going to say it's guesswork because it's not guesswork. It's trial and error to a certain degree. There are certain numbers we can use and certain numbers we can't use, and then from that we have to determine. So what we're going to do is we're going to type in our answer this time. So the dimensions that create the minimum perimeter are 10 by 4 and 8 by 5. In both cases, the perimeter would be 18, and I believe we're talking meters. Meters. Okay. So as I said, not an easy way to do it. Now on your sheet, you also have a second question, and this time they say that you can have decimals. What we're going to do is we're going to do that together in class, but we're going to use the graphing calculators. It's a little bit harder to do it online for a video lesson with the graphing calculators, so we'll spend some time together as a class to work on those. Good luck.